Hello everyone, this is week 12, the first lecture, and during this week we'll discuss how to solve linear systems of differential equations. Linear systems appear in many problems from physics, and we will consider examples of such problems at the end of this lecture. In such problems we have two unknown functions, let's say x of t and y of t. And these functions are connected by some equations, for example, like it's given here. And let's now discuss how we can solve such linear systems. And the first way is very similar to what we're doing in algebra. So this is the same as we do in algebra. So what we did in algebra, we eliminated one variable from the equations to get linear equation with respect to this variable and solve this equation, right? So we will try to do the same here. So we find, for example, let's denote these equations 1 and 2. For example, from equation 1, we find that the function y is, this is x prime minus 4t over 2. And let's substitute this function y into the second equation. Sub in 2, we obtain. So the first thing, y prime. So we have to find the first derivative of this thing. And the derivative is x double prime minus 4 over 2. Plus 2 times y. So this 2 and this 2 in the denominator will be cancelled. So we get just x prime minus 4t. Minus 4x equals to minus 4t minus 2. So let's now just rewrite this in a better way. So let's maybe multiply by 2 everything to get rid of this fraction here. What do we obtain? We obtain the second derivative of the function x, and the first derivative will have the coefficient 2. The function itself will have minus 4 times 2 will be minus 8x. And let's move everything else on the right side. So what do we have here? Minus 4t here and minus 4t here can be cancelled. And here we have minus 2 and minus 2. These two also can be cancelled. So in fact we have 0 on the right side. So this is second order linear homogeneous equation with constant coefficients. So we definitely know how to solve this, except just one thing, that we have initial value only for x. And to solve this initial value problem, we also need the initial value for the first derivative of x, right? So let's find it. X prime of 0. We can find, for example, from the first equation, just substituting 0 into the equation and moving to y on the right, we obtain 4 times 0 plus 2 times y of 0. This is 2 times y of 0, and y of 0 is given. This is minus 5. So this is 2 times minus 5 is minus 10. So that's it. We have the initial value for the derivative as well. And now solving this initial value problem with this equation here, we can find x of t. And now using this thing here, substituting x of t into, let's say, 3, then from 3 we can find y of t. And that's it. The system is solved. Okay, but sometimes to get these 3, sometimes not so easy. And let's consider another method which is applicable to more such systems. So, for example, if we have, let's say, if we have in the first system this thing and maybe also plus y prime and in this system we may have also plus x prime, then you see there is no way to find x and y from these two equations, right? So therefore we need another way to solve equations. So let's say the second method, and the second method will be based on usage of Laplace transform. So what we do, we apply Laplace transform to both sides of equations of the system. So Laplace transform of x prime minus 2, Laplace transform of y, let's denote by y, is 4 times Laplace transform of t. And the second equation, Laplace transform of y prime plus 2 Laplace transform of y, let's say just y, minus Laplace transform of x, let's say capital X, is Laplace transform of t minus 2 Laplace transform of just function 1. So we know the Laplace transform of derivative property. We know that this Laplace transform of derivative is s times the Laplace transform of function x and minus x of 0. So this is 4. Minus 2y is 4. And the Laplace transform of t is 1 over s squared. Laplace transform of y prime is sy and minus y of 0, which will be plus 5 in our case, plus 2y minus 4x. This is minus 4, 1 over s squared, minus 2. Laplace transform of y is 1 over s. So we get this system of functions now without any derivatives, right? Where the unknown functions are x and y. Let's maybe rewrite the system to make it more visible what we have here. So the coefficient of x in the first equation just s. The coefficient of y is minus 2. And let's move everything else on the right. Plus 4. So this 4 will move to the right. And here the coefficient of y is s plus 2. And the coefficient of x is minus 4x. So write minus 4x plus s plus 2y. This is equal to minus 4 over s squared minus 2 over s minus 5. So from this we need to find x and y. And then apply the inverse Laplace transform to find the functions x of t and y of t. So let's do this. So what can we do? We can eliminate y from the first equation. Let's maybe multiply by s plus 2, the first equation, minus 2s plus 2y. This is, and here let's maybe find the common denominator, just to write it simpler, multiply by s plus 2. And the second equation we multiply by 2. So this is minus 8x plus 2 s plus 2y. And this is, if we will find the common denominator here, okay, this is minus 4 minus 2s minus 5s squared, and everything multiplied by 2. And then we add these two to obtain that s plus 2 minus 8, this is coefficient of x, is equal to, and the sum of these two, so this is s squared 4 plus 4s squared s plus 2 plus 2 minus 4 minus 2s minus 5s squared. And you can check that from this equation we find that x of s is 4s minus 2 over s plus 4 s minus 2. Okay, so now what can we do? We use the method of partial fractions to rewrite this. Again, you can check that this is the same as 3 over s plus 4 plus 1 over s minus 2. So indeed, 3s, 1s, 4s minus 6 plus 4 is minus 2. So after this, we can find x of t applying the inverse Laplace transform to the function x. And from the table, we know that inverse Laplace transform of 1 over s plus 4t is just e to the minus 4t. And the inverse Laplace transform of this thing is e to the 2t. So this is the function x of t. Now to find y of t, we can use, so in fact there are two methods, right? Because you already know the capital X, you can find capital Y, and then do all these things to find the expression for Laplace transform of y, and then applying inverse Laplace transform find y of t. But this is really a long way, especially if you have precise formula for y. Let's find y using this formula. This is x prime minus 4t over 2. So x prime we can find easily, right? Since we already have x here. So this is 3. In fact, since we have derivative minus 4 times 3, this is minus 12 e to the minus 4t plus 2e to the 2t minus 4t over 2. So we just can divide everything by 2. We get minus 6 e to the minus 4t plus e to the 2t minus 2t. So this is the function y here. So that's it. The system is solved using the Laplace transform approach.